Hi folks, I'm Mr. V. Today's lesson is from Illustrative Mathematics, Unit 2 on Congruence, and this is Lesson 13, Proofs about Parallelograms. And if by the end of the lesson, what you should be able to do is to say, I can prove theorems about the diagonals of parallelograms. We start off by asking, what do you notice and what do you wonder? And please pause this video and answer this yourself if you're doing this for the first time. Some things that some students noticed: the diagonals of a parallelogram are not the same length. The four triangles are not all congruent. The diagonals of a rectangle seem to bisect each other. Pairs of parallelograms in both figures are congruent. So if I look here, it looks like these two triangles are congruent. These two might be congruent, but they're not all four congruent. We can also say some things students wondered. I wonder if the diagonals of the rectangle are the same length. I wonder if these two are the same length. The other thing a student wondered was, I wondered if do the diagonals of the parallelogram bisect each other. So does DB cut AC into two equal parts, AX and CX? Does AC cut DB into two equal parts? Does it bisect, cut into two parts that are congruent? Those are good things to wonder. And so here we have a conjecture. Diagonals of a parallelogram bisect each other. As you know, we make assertions. From those, we can make conjecture, and we can explore around and mess around with it and try to figure out, think that it works, and then we can go to a rigorous proof. Well, to go from a conjecture, like diagonals of a parallelogram bisect each other, to go to a proof, we need to have something more specific. So, for example, we start off with quadrilateral. We could start off with quadrilateral ABCD. In fact, I can even draw it kind of like a parallelogram. I'm going to draw it over here, and I'll label it. So here I have a parallelogram, and I have ABCD. But what do we know about a parallelogram? What's the definition of a parallelogram? Specifically, how do I write this information in the proof when what is given? And so they're saying, oh, it's a parallel. Given a parallelogram, prove the diagonals are congruent. I want to know more specifically, how would you write that in a way that, phrase your wording. A parallelogram is a quadrilateral with both pair of opposite sides parallel. It says nothing about the lengths. It says nothing about the diagonals. All it says is that AB is parallel to CD. So I could put that in my statement. And BC is parallel to AD. So I could write that in. Now we're trying to prove that the diagonals bisect each other. So I could draw the diagonals on here. And I could also label them. So I could say, given the diagonals AC and BD intersect at point E. Now the question is, how would you go about proving this? What do I need to prove? Well, what is the definition of bisect? What I'm trying to prove is that AE is equal to BCE and BE is equal to DE. That's what I'm trying to prove. I'm not going to mark it on the drawing. But that's what you're trying to prove when you're saying the diagonals bisect each other. On this next page, it says, here's the conjecture. Diagonals of a parallelogram bisect each other. Given parallelogram ABCD, such that AB is parallel to DC, and AD is parallel to BC, and AB is parallel to DC, with diagonals AC and BD intersecting at point E, prove that AE is equal to BC, CE, and BE is equal to DE. Now, here are the instructions that you can use to explore this conjecture. When we have a conjecture, we try to explore it and see if we can find a counterexample, see if there's a way that it doesn't work, and then we'll write the rigorous proof. And here's my explanation video that you can watch to show how to do that. Afterward, you can come up with some idea on how you might do it. And finally, we'll look at the activity synthesis. Here are two examples of student work. And we'll read this, and I'll mark the drawing as we go through it. It says here, because ABCD is a parallelogram. It's a parallelogram. That means that both pair of opposite sides are parallel, like this. And here they're saying that it intersects at X. Because it's a parallelogram, I know that the segments AD and CB are congruent, because there's a theorem that says Opposite sides of a parallelogram are congruent. And lines AD and CB are parallel by definition. So since these are parallel, since BD is a transversal crossing parallel lines, by the alternate interior angles theorem, these two angles have to be congruent. And I'm going to say that AC is also a transversal crossing those same parallel lines, so these two angles have to be congruent as well. I didn't say that in the write-up, and I should. This means that triangles ADX and CBX are congruent because you have angle, side, angle. And the angle, side, angle triangle congruence theorem says that this is enough information to prove these are congruent. And since they are congruent by the shortcut, I can say that the corresponding parts of the congruent triangles are congruent. So this segment is congruent to this one, and this one here, AX, is congruent to CX. And that's what we tried to prove. This means that AC bisects, or cuts this into two equal parts, and DB bisects this one, cuts it into two equal parts. There's a second proof here for you to read, and you can do this on your own. I'm not going to go through it now. This is a second way of doing this proof using rotations, and it's pretty cool. Next, we have a second thing to prove, and that is that ABCD is a parallelogram, with AB is parallel to CD and AD is parallel to BC. The diagonal AC is congruent to BD. So if the diagonals of a parallelogram are congruent, we're going to prove that this has to be a rectangle. And this activity we work backward. So we're not going to start at the end, or start at the beginning and go to the end. We're going to start at the end and go backward. So I'm going to walk you through this so that you can see it. I would know that this is a rectangle if I knew what has to be true for it to be a rectangle. For it to be a rectangle, all four angles have to be right angles. So if I knew that all four angles, angle A, B, C, and D, were all right angles, then I would know that it's and I could write that here, angles A, B, C, and D are right angles. Oh, wait a minute, look right here. I would know angles ABC and DCB were right angles if I, I would know these two are the right angles if I knew, well, let's see, just a minute. I'm going to mark on here that this is a parallelogram because this was given. I better mark that on here. Because in a parallelogram, this was given, and it was given that this segment is congruent to this one. So I would know that these two are both right angles since they're crossing parallel lines and they're same side interior angles if they were congruent. And then, it says in parentheses, I would know the other angles are also right angles because opposite angles in a parallelogram are congruent. So these two would also be congruent. So if these two are congruent and they have to add to 180, they have to be right angles. I would know angles ABC and DBC were congruent if I knew they were corresponding parts of two congruent triangles. Two congruent triangles. Which two triangles are we talking about? Well, I would know which triangles. Wait a minute, I'm talking about these two angles, A, B, C. This one is one of them. I'm talking about this other triangle. Let's see, it would be D, C, B, this one. I would know these two angles. This one is part of the purple one, and this is part of the blue one, were congruent if I would know that triangles A, B, C. Oh, I would know that angles, the corresponding parts. I'm going to just put CP, CP, C. The corresponding parts of the congruent triangles were congruent if I knew that triangles ABC and DCB were congruent. I would know, I'm going to go back and just copy this over. These two triangles are congruent if I could use the side, triangle terms. And I know I could use the side if I knew that BC is equal to CB, because I have to have all three sides. Let's see, DC is equal to AB, and DB is equal to AC. Well, we know DB, AB, and DC are congruent because they're part of a parallelogram. And in a parallelogram, both pair of opposite sides are congruent. So I know that this is congruent to this one. We also know that these two sides are congruent because that was given. And this is congruent to itself because it's the reflexive property. Let me show you the beauty of this. Working it backward is a good way to do this, because if I work it backwards, then when I go to work it forward, I can follow the logic. First of all, we're given, and I'll do this in black because it's given, we're given this is a parallelogram. This is congruent, parallel to this, and AB is congruent to CD, is parallel to CD. We're also given that the diagonals are congruent, so AC is congruent to DB. Now, if I'm working my proof backward, I would say, well, these two sides are congruent. Opposite sides of a parallelogram are congruent, so these two sides have to be congruent. By the reflexive property, this is congruent to itself. Here I have two triangles, one DCB and one ABC. These are congruent by the side-side-side triangle congruence theorem. Since they are congruent, the corresponding parts of the congruent triangles are congruent. I'll mark this in a different color. Let's see. That means that this angle has to be congruent to this one. Oh, these are same-side interior angles formed by a transversal crossing parallel lines DC and AB, and they must be supplementary, which means that this angle has to be a right angle and this angle has to be a right angle. And since this is a parallelogram, opposite angles are congruent, so angle D has to be a right angle and angle A has to be a right angle. This has to be a parallelogram. It has to be a rectangle. And now we go back to our lesson. Excuse me. For lesson synthesis, we know that an if this then that statement can be, the converse of it is if that then this. We change the arguments, and so far we've looked at several of them that are true. They don't always have to be true, and if they're both true, then this is an if and only if statement. So quadrilaterals are parallelogram if its diagonals bisect each other. If a quadrilateral's diagonals bisect each other, then it's a parallelogram. In other words, statement 2 here, a quadrilateral is a parallelogram if and only if its diagonals bisect each other. Now, not all statements and their converses are true. So here's a true statement. A person's a parent if they are mother. Is the converse true? Is a person a mother only if they are, let's see. If a person is a parent if and only if the person is a mother? No, it could be a father, of course. A person is a vegan if and only if that person doesn't eat animal products. Well, a person who doesn't eat animal products is a vegan, so that would be true both directions. So it's an if and only if statement. For the cool down, I want you to take the proof that we did and to write it out backward. Also, notice here is the actual proof that we used, and so you can use it to write it backwards. Please read the lesson summary. Good luck and success.